talk today is going to be about some of the things that we have implemented there. So I'm going to touch on a few different topics within CI, because my view on CI is that it's not just, okay, we have a tool like Jenkins or we have the build running, but there's a lot more depth to it, and there's a lot of stuff that you can do within CI even before you get into CD-related activities. So I've got about 5 or 6 sort of core topics that I'll run through and talk about sort of our story of how we got to where we are now. And where we are now, I think, is a pretty mature and resilient CI environment. Anyway, my name's Jacob. I'm CTO and co-founder of a small consultancy company called Verifa, and we're specializing in services around CI/CD and DevOps style practices. So we try and use basically what's best in the world and as much open source as possible to solve challenges that we encounter in companies. The way I see it is that a lot of the challenges we encounter are very much the same, but the devil is always in the detail. So what we do is we try and come in and help make sense of things and also give some kind of direction, and then some manpower behind these things too. I'm also a musician, been playing piano since a young age. I do juggling as a hobby, and I'm a rollerblader, and I like to travel around the world. So I live in Finland now, but I'm Swedish born and grew up in England, so I don't really belong anywhere. And yeah, I like technology, so I've been playing around with a lot of things for quite some time now. I started with Jenkins around 2011, developing plugins and doing different things with it, so I'm pretty familiar with that now. And more recently, learning container technologies and things like Docker and Kubernetes for the last couple of years, and trying to tie those together. So. I'm going to give a brief introduction now about Siemens Healthcare and Point of Care, which is the business unit I've been working with. I'll give a little brief introduction to Verifa as well, the company that I come from, and then we'll sort of get to the meat of the presentation. So I hope you enjoy. Well, Siemens Healthcare is huge. They are pioneers in a lot of healthcare-related products, and the division I was working or have been working with is Point of Care. What that means is they develop medical devices at the point of care. So if you go to a doctor and you want something, they will have devices that the doctors can use themselves. So if you want to have a urine sample, some blood test, they will take the sample, they will put it in a machine, and they will get the results at the point of care. There's a couple of challenges there with everything being real-time and critical. So basically, we can't delay readings because they're supposed to be instantaneous. And the next generation devices that they've been developing are now Android-based with a handheld tablet that the doctors will use, and then an engine, as we call it, which is where the actual analyses take place. So this is where the whole IoT thing comes in now as well, because we have Android devices being connected to different engines, which can be used for different purposes. Again, blood gas analysis versus urine analysis. That was the product line where we've been focusing our new work on. So there's been a mix of embedded C# with Windows CE, QNX type C++, embedded engines, and then Android-based products on top of that too. And I'll go into a bit more detail when it's relevant for the different topics that I'm going to cover. But that's the basis of it. Verifa, like I said, we do a lot of things, right? Because we help people and people have problems. So we end up getting involved in a lot of different areas. The main topic is sort of CI/CD. We help with infrastructure, we help with testing, we help with defining pipelines. So this TX stuff, which is written here in the top right, is something that we have used as a definition to help people define what done means. You can't simply run every type of testing that you want to do up until a release on every single code change. So TX is our way of defining what kind of testing we run at which stage in the pipeline. And this TX becomes T0, T1, T2, T3, and T4, and different terminologies there. So T0 is one of the most obvious ones, which is, a developer is sat working on code. that would be T0 when we run the analysis as early as possible. And you might say that unit testing falls into T0 because developers can run unit tests locally. Static analysis might fall into T0 because they can do that locally. But would performance type testing, testing, or some kind of OSS clearing and these sorts of activities that wouldn't necessarily fall into T0. So then we have T1, T2, and T3, which are usually run by some kind of CI engine, whether it's Jenkins or not. So if anybody has more questions about that, we're over at booth 915. I'm going to be here the next 2 days, so please come and talk. I like to talk with people, so yeah. Cool. About the Siemens project, there's always a question of motivation whenever people are engaging in changing things and transformational changes. So our story is not very different to everybody else's, and I took this from Atlassian. I found it some years ago, and I think it's just great because this really project managers, project leads, team leads, even developers can really relate to this. The emotional cycle of manual delivery as opposed to automated delivery. And I think all the things you'll see here today in terms of visualizing data and understanding where we are in the data value stream and so on and so forth is basically, if you don't have any of that, this is where you're going to be. And every time I bring this up when I'm in projects and stuff, people can usually relate. So this is what we wanted to avoid. I would say we've avoided it as much as possible, which is great. But unlike modern projects where we're talking about delivering fast, our goal was on code quality. So it's a regulated environment, FDA regulated because it's medical. Things are embedded, things are in restricted hospital networks. We don't have the luxury of being able to deploy every time we make a change. So we want to make sure that when we do ship, which is going to be every couple of months or so, that we ship something that actually works and is of serious quality, because if it's not, the effort we have to go through to update that is a lot more than, for example, some web service providers. So. Same pain, but slightly different goal. The goal is on quality over, shipping fast. So there's always a sort of tipping point there. So yeah, our journey towards modern CI. So we were like, right, okay, we've got all these things we want to do to help with our CI environment. So we're going to build a pipeline, and in that pipeline, we're going to have the build of the software, right? So the build has to work every time. We're going to put static code analysis into our CI pipeline. I've worked a lot with static analysis and testing tools because that's my background before I got more involved with CI-related activities. So when we're talking about putting static analysis into our pipelines, we're not just talking about, okay, let's pick a tool like PCLint or some open source tool and run it and put some results somewhere. It's like, what do we actually want from static analysis? What is the benefit of having it there? So we usually categorize it into a few different things. We have things like coding guidelines, so we have to comply with some kind of coding standard. It might be MISRA or AUTOSAR, or looking at security guidelines like CWE and CERT, and sort of defining what it is that we want to get from static analysis tools. And also knowing that there's not just one static analysis tool that's going to suit all your needs, but maybe a combination of different tools is going to solve the real sort of, well, give us the most benefit out of static analysis. So I don't know how many static analysis tools we have in our pipelines for projects, sometimes 5, sometimes 6. They do lots of different things for us. Some are really good at finding like deep defects, so they do path analysis in the code. Others give us simple coding guidelines violations, and others are more focused on security-style checkers, so array buffer overflows and cross-site scripting and these sorts of things. We want architecture analysis as well. So I'm going to talk a bit more about this later, but we had a common scenario here where we had a platform team developing an Android platform. So basically 15 to 20 Android libraries that were then going to be extended by the product teams so that we could reuse as much as possible. Very good idea, great for business, very difficult to do. And one of the key things we wanted to get right here was architecture. And what I mean by architecture is the structure of the code. So dependencies, inherent dependencies, and making sure that we don't get an utter piece of spaghetti code where we need to depend on one part of the platform, and we actually end up depending on all of the platform. And if there's one change in any part of the platform, the whole platform is affected. That was exactly what we wanted to avoid. So we built architectural rules to help us find violations of our design. So we had a design in Enterprise Architect. We implemented that into our pipeline to make sure that if a developer adds a new piece of code, adds a new dependency into the code, then we would flag that new architectural violation. We wanted to put unit testing in there. I'm sure everybody knows what unit testing is. One little extra thing we put in there as well is mutation testing. So mutation testing is take your standard unit tests, look at the software under test, flip the bits. So if you got a greater than, make that a less than. And now rerun your unit test. Would you expect your unit test to still pass? If your unit test still passes, then you might want to think, is the success criteria strict enough? Or have we basically just written a unit test that exercises the code? So mutation testing is a way of measuring the quality of your unit tests. Integration testing, so again, the next level up from unit testing. We wanted to add verification testing in there as well, so this is now based more on requirements or features and so on. We wanted to add performance testing in there too, so it might run once, but what if we run the same test for a month? Does the system still work after a month? We wanted to have some kind of way of automatically managing our artifacts and having traceability into those. We wanted to build in open source software compliance, so this is looking at licenses, security vulnerabilities and such of libraries that we use. And then we wanted to add the next thing in, right? We wanted to create a foundational pipeline that would include as much as possible to automate everything we need to do from dev to release. And I actually just put this point about the next thing on there because I ran out of space, which is kind of the point of this slide, right? There's a lot of stuff you want to do, and we only have so much time. And however modern you are with Kubernetes and multi-clusters and stuff, running all of these tasks in parallel even can still take time. I mean, if we look at the performance testing, the stuff we're doing now can last from 2 weeks to 4 weeks, and that's by design. I mean, that's the test, right? We can't simulate something running for 2 weeks without running it for 2 weeks. We have a challenge here. We need to find some kind of balance between completeness and feedback time. And that's almost exactly where our definition of TX came from. And this was actually one of our first designs that we made, or plans that we made for Siemens to help them with this. So this is quite small, but I can just talk you through it in a high level. We have, can you see the red? I can't. Anyway, the top bit is the development team. So basically, we want developers to take whatever tasks and things they're supposed to be working on from Jira or TFS. But when they develop the code, we would define this T0. So T0, again, is time zero, so the earliest possible point that we can start running any kind of analysis. We don't have a quality gate there. It's just you should run some static analysis, you should run your unit tests, make sure this stuff passed, because when you do push your changes to the version control system, we will be running a pipeline and we will be running these things again. And if you haven't passed, well, then you need to go back and fix your work, right? So building basic quality gates into the development process so that, again, things like architecture, things like coding guidelines, things like unit tests are a basic fundamental need that you have to have together with your code. And then as we go down these blocks, on the left-hand side here, we start to look at T1, T2, and T3. And we define these based on whether it's a feature branch, whether it's an integration branch, whether it's a quality branch or a release branch. Those would be the different Ts. So a feature branch would be T1, right? One individual or a group of individuals are working on a feature. We would then define a set of quality criteria for T1. So in this case, it could be, well, actually, in this case, it is static code analysis, unit testing, and integration testing. So we finished there. If all of that passes, you're good. You can merge up to the integration branch or the shared development branch. And then we run the same thing again, but a little bit more. So it's kind of like a pyramid. The closer you get to being able to release, the more thorough we are with the tests. And this is how we balance that strike between thoroughness and feedback times. And then further on down here as well, we get the verification and validation side, which is the more thorough, more detailed, more well-documented, the stuff that the FDA would come in and regulate. And then right at the bottom, we have our, our manual testing team. So due to the nature of our project, we cannot avoid manual testing. We had quotes from robotics teams and things to develop robots to help us test the stuff manually, but it's just it's just not worth the hassle. So the goal was that when the manual testers come to do the manual testing, we are completely confident that we've done everything we can in terms of automation so that they don't, set all the rigs and everything up, run the first test, and suddenly we have a crash, right? Because that's cost. That's exactly what we're avoiding. If they can come in and run all their tests as more of a formality rather than actually looking for bugs, then that's what we're aiming for, right? Cool. So we had this great idea, this great design, and we were like, okay, let's start doing it. So we did what every other team does, and I've been in this story a few times now, and it's to me it feels like a routine that I need to go through with companies just to help them understand a little bit. We wanted to set up Jenkins as a CI system because well, we're an embedded, and it's the safest choice in my opinion, even today. If you're hosting on-site, you've got your own infrastructure. People know Jenkins. There's lots of help available online. And, well, I was kind of leading this, and I like Jenkins. So. Anyway, as a proof of concept, we had one server. So, all the bits of Jenkins on that one machine, the JVM, the build executors, and the Jenkins file system, which stores the configuration, the build artifacts, and the workspaces. It was all configured manually. Here's a Windows machine, install Jenkins, run it up. Oh, we need this plugin, this plugin, this plugin, and configure the jobs and such. Well, we hit a bottleneck, and maybe some of you have seen this guy. This is Jenkinstein. So this is a very, very, very common pitfall of Jenkins where you don't follow best practices and you don't take the time to do things well. You kind of just set it up and boom, it exploded. And it exploded on us, as I was expecting. But when it did explode, that's when I had my little card to play that, hey, we need better infrastructure now. Can we get some better infrastructure? So hence why I said that this is a bit of a routine. Sometimes this needs to happen so that people realize the problem, and then you can do something about it. So once we got over that hurdle, and we were like, okay, production grade CI environment, the requirements, it has to scale, has to be resilient, and we want ultimate control over it. We don't want people going in and installing 15 different plugins until they find the one that's right for them, and then they leave the other 14 plugins lying around. Somebody comes around later and is like, oh, there's a plugin here, are we using this? And then tens of minutes are wasted in email threads back and forth talking about plugins. I'm sure a lot of you have been there. So solution, was it a year and a half or so ago now that the first official release of Jenkins Configuration as Code plugin was released? So this is a really, really, really cool project, and those of you who are using Jenkins and aren't working with Jenkins Configuration as Code, I can really strongly recommend it. So there are ways to provision Jenkins masters using code, and this has been done with Groovy scripting, and it's pretty not nice. I don't want to say horrible because it works and it's nice and people have used it, but it's there's a learning curve, and if you set stuff up and then somebody else comes in afterwards to debug it and maybe add to it, it's not the easiest thing to do. Jenkins Configuration as Code is a way to define your Jenkins master using YAML definition. So it's much more high level, much more human readable, and much easier to manage. We then created a Docker swarm locally. We had a couple of Linux servers, so we created a Docker swarm out of those, and then we maintain our Jenkins master as anybody here would maintain their real project in the real world. We store all our configurations in Git. We have pipelines to build the Jenkins Docker images. Nobody can update the Jenkins master configurations without going through a pull request, so the whole team is aware of what's going on and changes are being made. And basically things don't break. Our Jenkins master is minimalistic, and we're very happy. Yeah, last point there as well, our Windows agents, because we're building on Windows, that's the platform we decided to ship and so on. So our Windows agents are still managed manually at the moment, but we're moving towards Azure and using Terraform and Ansible and stuff to provision those. But we solved the problem of our Jenkins master, and yeah. Cool. So the actual pipelines that we wanted to create, right? Now we have a structured, stable, controlled Jenkins master. Now we actually wanted to go and define our pipeline. So the background that I just went through a moment ago was we have a lot of things that we want to run. We don't have so much time because we want feedback. So how do we balance this? And this is the TX stuff that I talked about earlier. If you're using Git and you have the multi-branch pipelines available, then you can do this with the when conditions in pipelines. You can write when branch dev or when branch, whatever, do this. We are using TFVC in some of our projects, so we didn't have this luxury. And we came up with a way of using parameterized Jenkins pipelines. So our Jenkins master doesn't just provision the actual Jenkins master, it provisions all the pipelines as well. And those pipelines now have parameters. So basic things like do build, do static code analysis, do unit test. And then we reference these parameters in the Jenkins files, in the Jenkins pipelines themselves. So this way we can create our Jenkins master with all the hundreds of jobs, all with parameterized pipelines. And then those pipelines themselves have these, when do build, do the build. When do static code analysis, run static analysis. So, this is how we defined our sort of feedback loops for the different types of pipelines. With a bit more detail, the way that works is we have our Docker file, so our base Docker file that builds our image for the Jenkins master. It contains the Jenkins YAML file, so this is the Jenkins configuration as code bit, and it contains a C job, which is a Groovy script which creates our Jenkins pipeline. So if you just run this Docker image, you'll have your production ready Jenkins master with all the jobs and everything created. And yeah, that contains a bunch of environment variables that we use. So if people want to update, for example, the SonarQube URL or a URL for another tool, then you do that in the YAML file, and that's referenced everywhere in all the pipelines and, well, wherever else we need to reference it. We can pass that to random scripts that we've created. So we've tried abstracting as much as possible. We have the nodes listed in there, and of course we have the pipelines as well with the the do build or do static code analysis parameters. And then that's deployed on our Docker Swarm cluster. And we're following basic dry principles, don't repeat yourself. So all the values that we can abstract, put them in the highest possible level. And the actual logic of pipelines is not within the pipelines themselves, but in the C job. So when we create the pipelines within Jenkins with the parameters, that's the logic. And then the actual Jenkins files themselves just have a when do build, for example. If anybody wants to learn more about this, then come talk to me afterwards, because this, for me, was quite revolutionary. It was the first time I'd been doing this in a project, and it solved a lot of problems with updating, managing jobs, managing pipelines, and so on. Cool. Next topic then. So I talked a little bit earlier about the this common platform that we were developing. So we had to manage our artifacts somehow. The original plan had been to build a bunch of Android libraries and such, put them in a zip file and send that zip file to the product team, which, well, doesn't seem so crazy when you're involved in a project, but coming from an external perspective, that sounds time-consuming and very manual. So we have a basic setup where we have an app, and that app has, let's say, 2 core assets. It could be more, dependent on it. So the main questions were how can the platform teams build and test these things, and then how can the product teams reuse these tests and basically be sure that what they're getting delivered is good. So we set up Artifactory just over 2 years ago as our central repository. So basically the platform teams build and push and deploy to Artifactory, and then the product teams can just reference those artifacts from Artifactory. So the pipelines take care of all this for us. It's basically automated. If you make a change and you push that to version control, you'll get a new artifact being published to Artifactory with a new version and new test results and so on there, so that the product teams can now consume this new version if they want to. Sorry. I came in a bit late last night, so I'm still adjusting to the time zone. And the way the versions are managed are with TFEC labels, so you can use Git tags and things as well in a similar way. And that way you have traceability between the actual version of the source code, the artifact being published, and then in Jenkins all the tests and things that are being run. So we have this traceability. If somebody says I'm using version 123 of core asset A, then we can immediately go and find exactly which version of the code that was and find all the test results and everything else we want about that artifact. Yeah. So we had that picture is nice before I put the bottom bit in, but then you start to realize that these core assets have about 1,000 different dependencies on them. We use Node.js and Gradle. So somebody puts in a dependency, especially in Node.js, and boom. Boom. I'm sure people are aware of this. You suddenly get hundreds, if not thousands, of transitive dependencies being pulled in. And we also have a dependency from one of the core assets on another core asset. So the plot thickens a bit here, as is common. So the workflow that we have for this, and this is all orchestrated in the logic that I talked about earlier with the Jenkins pipelines. So the triggering of the different pipelines is ordered so that we build the first core asset, and then we build the second core asset, and then if there's more core assets, and then finally the app. Those are downstream pipelines in Jenkins. So yeah, we pull in all our third-party dependencies from Artifactory, and then we publish a new version. So here it's version 0.0.23, for instance. We then get to core asset Y. We pull in the third-party dependencies plus the core asset X, version 0.0.23 if we want to, and then publish a version of core asset Y into Artifactory. And then when we get to build our app, we do the same thing again. So we're basically pushing and pulling from Artifactory as part of our workflow. To look at that in a little bit more detail in terms of the pipelines, when our pipelines start, we get the latest version, we update it, and we apply that new version. We then build the software, we publish the artifact to Artifactory, and we then apply the label within TFEC so that next time we come to start this again, that next label is there in the system. And then we trigger the downstream, which will start the next core asset building and such. So this is the basic workflow of how we're managing our platform and the different core assets, and this will finally get down to the app where we trigger the downstream app to build. Yeah, so that's the piece of managing artifacts and how we have solved that. So the next topic, Siemens are very big on using open source properly. So not just pulling in lots of libraries, but they have a pretty thorough process for going through and getting libraries approved that you want to use. And this is obviously a great area then for automation. And this is actually an area that usually when I talk about, people suddenly perk up a bit, because I think everybody has pain here. Every developer who wants to use different libraries either has to fill in Excel sheets, or they have to send emails, or they have to do something that's not very fun in order to get to use a library. And at the end of the day, the product owner or whoever is responsible for shipping the product and making sure that the documentation for this is available also hates this. It usually creates a lot of friction within teams, and like I said, a really good opportunity for automation. So this diagram should illustrate a little bit about what we've done. It's not specific to the project at Siemens, but it's quite an overview of a few different projects we're involved with. So if you look at this sort of downstepping pipeline here in a way, it's a shame this pointer doesn't really work. But you run the basic build. As part of the pipeline, we're then creating the bill of materials. So this is identifying all of the third-party libraries that we're using in our project. We create the bill of materials in a JSON format, YAML format, whatever format we want. and we then synchronize that with some kind of tool which stores a database of all the projects and all the libraries involved in those projects. So there is an open source tool and an initiative called Software 360, which is mainly developed by Siemens and Bosch. We are also now contributing to the project and have been for some time because it's open source, it's free, and it's really great. And it's basically a back-end for managing your OSS compliance. So every time we run this pipeline, we create the new bill of materials and we synchronize it with this database, and we get a diff of what's new, what's already known, has it been cleared, is there a violating license, is there something in there that shouldn't be. And we've also hooked these, this backend up to different vulnerability databases, to the legal team, to the product owner. Basically, everybody is connected about what third-party and OSS libraries we are using in our projects. So, the idea here is that once we create this baseline, and once we have cleared all the libraries being used so far, then the next time we run the pipeline, unless something has changed, we should be cleared automatically, right? And we can generate OSS README files. We can generate any compliance reports that we need. We can basically have continuous compliance on the OSS side. And if somebody pulls in a new library, that isn't known yet and might be a violating library, like a GPL or a copyleft license, then we know about it immediately, not 2 or 3 months later when suddenly we have to refactor a large part of the project. So, this topic is not particularly, I think the OSS compliance stuff is always oversimplified. People are like, yeah, this sounds really easy, and it should be really easy, but because it affects so many people within an organization, I always find it much more difficult to actually do in practice. Yeah, if, again, anybody wants to talk to me about this stuff, then please grab me after this. As I'm going quite quickly over these topics right now for the sake of time. Automated testing. So obviously we wanted to add some kind of automated testing into our pipelines as well, so we don't have to do that manually. We have a slight challenge because, again, it's medical and we have hospital networks and such that we need to work within. So our basic setup of how our products will look in the real world is there'll be an Android app, and it will be connected to Bluetooth with an engine. So this will be the embedded part here in the bottom left. And then the Android app will also be connected to some kind of secure database where we will store the information about patients and such, and the test results, of course. And all of this will be offline in a hospital network. So we had to simulate this for our testing purposes, which took a bit longer than it should have done, but hey-ho. Right, so we have an R&D network within Siemens where we can do this stuff and trial it as much as possible, right? So we set up some desktop machines there. We connected Android devices via USB to these desktop machines. We created emulators that would emulate the engine, and connected those emulators to the Android app via Bluetooth. And we also created an emulator for the database and connected that via this secure protocol we're using to our Android tablet. So this wasn't particularly easy, but it was completely necessary in my opinion. This is one of those times where you start to think that all this effort we're putting into creating test environments, is it worth it or is it not? Once you've done it and you start running tests and you get value from your tests, you very, very, very quickly see that this was totally worth it, because now every time we make a change, we can run through our entire regression suite and get up-to-date results about the status of our projects. Anyway, we built one of these and we replicated it a few times, for scalability and parallelization, and then we put a controller on top of it, or a dashboard. So we're actually using a commercial tool from a company in Finland, not far from where I'm based. I mean, it's in the same country. I didn't know about them before this project, though, so that was nice to get to meet people in a small country. They have a tool specialized for Android testing, which provides this server, this dashboard at the top, and then you can connect agents to your controller. So all we need to do to run this in our CI environment is basically send a test request to this controller at the top. Our different nodes connected to that controller are labeled with branches, with projects, with however we want to identify them. So we say, run this test request on project ABC, and it will just find an available node, launch the project, or launch the tests on that node, and then give us the results back to the controller. So we have like an API which we can query via REST and get any kind of information we want out of it. So there's very, very much more stuff here that I would like to talk about, but yeah, this was like the the skeleton of our test rig that we set up, and now we run our integration tests there. We run the verification tests. We run the performance tests there as well. In fact, that's a nice feature of what we got working here. The performance tests that we run are actually just the same as the verification or integration tests. We just kind of randomize the tests, and then we just run them for much longer. So why create a separate performance testing rig when you can just reuse what you already have and reuse all the tests that you already have and get performance tests out of that? What we had to do to make this work is obviously make sure that the tests are written well. So all the tests are idempotent. They can be run in any order that we want. They're not dependent on ones before them. But once we achieved that, then now we have the capability of running performance tests as part of our CI environment. Cool. I think this is the penultimate topic. So I think this is growing much more as a topic now from what I see when I travel around and see different companies, people do more and more testing, and then there's always a challenge of how do we actually deal with any of the results? How do we actually use any of the results? And it's a challenge that we came across as well, naturally. So our basic setup is that we use SonarQube for anything relating to code quality in terms of static code analysis, architectural violations, unit testing, code coverage. Any of those sorts of bits of information should always go to SonarQube. So I talked earlier about us using like 5 different static analysis tools. The way that works is because SonarQube is the dashboard, right? So a developer doesn't need to care what tool we're using because the results are in SonarQube and they'll be tagged with, coming from tool X. Obviously, the people maintaining the pipeline need to know this, but yeah. So we have a standardized dashboard for anything related to code quality. We obviously have Jenkins, so this is a screenshot of our pipelines. We have Jenkins for the orchestration of the CI and the different tasks and steps that need to be run in there. In the bottom left here, this is the Android testing tool that we're using called Tau. And this provides, it has a profiling engine, so it captures basically everything going on in terms of the services running, battery usage, memory usage, any crashes that occur, and creates stability scores of our test runs. It's just packed full of information. And we only probably use about 1/3 of it or 1/4 of it at the moment, either pulling it out via REST APIs or actually creating links to the different test runs and things to make them available. And our latest initiative, which isn't really done yet, but we did start playing around with it, is here in the bottom right. And this is a open source tool called Mosaic, which is a basic framework that uses React, and you can create different widgets and things on there. So we wanted to pool all of this information together into one dashboard so that anybody can go to this dashboard and see for project X, what's the latest status with the pipelines, what's the latest status with code quality, what's the latest status with all the open tasks in TFS, and how's the sprint burn down going, and how's the stability score from say, our testing environment. So yeah, we spent quite a bit of time on making sure that the information in here was valid and relevant, and then shared it with the correct people. And I guess if you attended the keynote earlier today, when you make useful information available, people do actually use it, which is really nice. And we've had exactly the same thing happen here. When builds were failing, when tests were failing, developers weren't asking, the lead or whoever what's going on. They went straight to Jenkins now. And now we just saved, 10, 15 minutes of a team lead's time. So these small bits of time saving are huge in the long run. Cool, so that was the last topic that I wanted to touch on. And in terms of our future plans, we've been talking about continuous everything for a couple of years now because, well, once you start doing stuff, you can't stop doing it. You have to do that plus more, and then kind of everything becomes continuous after a while. The one thing I find interesting about this is that the more mature, the more developed your CI practices become, the more time you have to then start focusing on the next activities. So our next big push now is going to be moving more in towards the continuous delivery or the CD realm, looking at basically tracking features, tasks, what is the definition of done in terms of implementing something, and bringing this information into the CI cycle so that we're not just looking at testing and code quality and architecture, but the bigger picture of delivering features to, well, not just the customers, but as a platform team, your customer is basically the product team, right? So when I'm looking at it from the platforms team perspective, the product team is the customer. So what information do they need to start developing on the latest features in the platform team? And DocOps is another thing that we've been talking about for some time now as well, is basically can we generate all the requirements traceability, the test traceability, and all of those kinds of documents digitally as well, so that we don't have to go and create those ourselves at the end. Basically, can we create an artifact which has all the traceability we need with all the documents we need to then ship that either to the FDA for audit or to our end customer? And the final thing, as always, is keep learning and adapting to new changes. There's always new tools and new things coming out, and I'm one of the kind of guys who's a bit pessimistic, but also very optimistic about new tools. So I like to design things so that if a tool or a framework or something becomes obsolete, it wouldn't be too much effort to pull that out and replace it with something else. And one of the main challenges we've come across with trying to do this is human ops. Basically, we can create the most amazing CI environment ever, but how do you actually get people to use it and to adapt it? And once you've created it, you need feedback. You need people to grow together with it. So, yeah, that's part of our continuous everything, is continuous learning and continuous adapting. So, yeah, in summary, we have a pipeline which automates a lot of tasks from dev to release. And I would say it's been invaluable in really speeding up the velocity of development. We have traceability between version control tools and package management, and the package management is automated. And we have basically an entire testing environment set up to help us validate things continuously. Then we have visualizations and reporting and everything else we need on top of that as well. This has been, the main topics of what we have done to help us achieve a mature CI environment. So hopefully some of these points here are things you're already doing. Hopefully some of them might be new and good inspiration for you. So I hope you found this talk useful and interesting. And like I said, if anybody wants to come and talk to me about anything, just grab me or throw something at me. I'm a juggler, so I can catch things pretty well. Yeah, so, oh, yeah, question?
So I got two questions. You probably answer them both at once. First question is, how varied were your tech stacks across all your different development teams as you tried to think about providing a set of shared services? How hard did that make it, and were there things you thought about to try to help with that problem? Something we certainly deal with a lot. And then the second question is, how many different target platforms were you working on? I saw you talk about emulation on one of your slides. What did you need to do, or is there anything you needed to do to create emulation? Was that an effort that you had to undertake, or were there things that existed in that domain when you try to think about the embedded side?
Yeah, good question. So the first question was about the environment. So we didn't have a huge stack. We had people using in Visual Studio and C#, and then we had people doing the real low-level C++ with QNX and Momentix IDE. Generally, we didn't come across any challenges in terms of aligning them with the same tooling, because one of the things that we tried to achieve was not that, hey, you have to use this tool, but you have to satisfy this criteria. So you have to follow coding guidelines, you have to follow some security coding guidelines, and you have to have some kind of sophisticated static analysis tool. And then once you put something like SonarQube in place, then which language, which development environment you're in, it becomes obsolete. I think to supplement that answer as well is if you don't have a quality gate, or whatever you want to call it, at the developer desktop, but you put CI as the quality gate, so as soon as somebody pushes a change, you can run the pipeline, then the need to tightly integrate with development environments is not so necessary. If you follow that. If you put the quality gate at the developer desktop, then you need to have everything there, and everything needs to work. Whereas if you put it in the pipeline, then we already have our environments defined there and managed, so it's good. The second question.
Emulation.
Oh yeah, okay. So like I said, some of the testing we're doing is still manual, and it has to be because of the nature of the engines. So the emulators are kind of the replacement for the engine to test the Android side. So there wasn't much effort needed there because the developers were already creating this so that they could run things locally in their environment. So when we came in, they said, we already have this, and we were like, okay, great. We just need to change it a little bit so that we can put configuration files in there, we can pass parameters to it, and we can run it from the from the command line and also together with our test environment. So yeah, that was our experience. Yeah. How what, sorry? How large was our DevOps team? So we had about 30 engineers, so it's not a huge project. Our DevOps team was at peak around 6 people. We went sort of up and down depending on the different activities we're involved with. So for example, the OSS tasks, there's a guy in my company who specializes just in that, so we brought him in just for temporarily to help us set that up and get trained. But we're going down to around 3 or 4 full-time people working on these sorts of activities. So per 10 engineers, we have 1 DevOps person. And those engineers, they can be requirements, developers, testers, and so on. Yeah?
So you said that you're still working on DocOps.
Yeah.
My question is, do you use anything in your pipeline as objective evidence in your 510K submission or for regulatory authority objective audit?
Yeah, I could talk to you about that for hours. Yeah.
I'm a farmer, just creating my pipeline.
Yeah. I think this is a human ops topic mainly, so this tool, if I go back, sorry. In the bottom left here, the testing tool that we use for Android, as an example, records videos, takes snapshots, has everything that we need, and it has an API for it. Unfortunately, the discussion has moved more to how big is a video file, and apparently 1 gig is massive, which to me it's not that big. Yeah, we can get all the objective evidence there, but making sure that it satisfies everybody's criteria has been the real challenge.
Have you had to show anything from your pipeline to an auditor?
Yeah, so this is another interesting topic why I said this could go on for hours. The policy is not to show anything from our live environments. Have it available, export it, create a zip file or something, and then that's what we show. And I think generally it's a good practice when you have auditors coming in as well, because as soon as you show them your live environment, they can start to dig around and probably see things that you might not want them to see. So yeah, that's been my general consensus that I hear when I travel around. Yeah. Okay. Well, if anybody wants to ask, then, like I said, I'm around. Otherwise, thank you so much for your attention, and hope you enjoy the rest of the conference.